Today we're going to talk about an ellipse, and an ellipse looks a lot like a circle, but just kind of squished on one side. Kind of imagine taking a circle and squishing it down this way or this way. So you have a section of your graph or a side of your graph that is longer than the other side. And so the longer side, or the longer, I guess, think of it as an axis of your ellipse that is along an x-axis, is called your horizontal. So the horizontal axis goes this way, all right? And that, you can see, is longer than the vertical axis. And all of your main pieces fall on that axis. Your center, you have what's called your focus or your foci. And then these two on the ends are your vertices. All right. So those are the ones here on the ends that are on the same axis as your focus and your center. And then on the shorter axis, this is your covertex, or covertices. All right. And now there are very specific distances from the center to each of these. So the distance from the center to your covertex is the value b. The distance from your center to your focus is the value c. And the distance from your center to the farthest distance away, which is your vertex, is the distance a. And so you have all these different pieces of your ellipse. The same is going to be for the ellipse that's a vertical axis. So again, our vertical axis is the one that goes like a north-south. That is the longer axis, or has a longer distance from the center to the edge of the ellipse versus from the center to the other edge. And again, the names are the same. Right? This is a vertex and a vertex. And again, the distance from the vertex to the center has a distance of a. Right? From my focus to my center is c. And again, this is a covertex on the edge of the smaller axis. And that has a distance of b, just like it was on the horizontal axis. And so if you look over to the left, all right, we have these variables. And it says the distance from the center to the vertex. Again, I've been already labeling some of these for you, is a. From the center to the covertex is b, and the center to the focus is c. So let's look at the standard forms. All right. And so it's telling you the standard form equation of ellipse that has a center at 0, 0. And again, we call them major and minor axes. All right. So this axis way up here, that is the longer axis. All right, the one that we say this is our vertical axis, that would be considered our major axis. And the smaller axis that has the covertex, that's the minor axis, because it's a smaller distance. All right. Same thing up here. This would be my minor because it's the shorter distance. And this would be my major because it's the longer distance. And again, the major axis is the same as the horizontal or the vertical. And so what it tells you is that it tells you the lengths of those axes are 2a and 2b. All right, so that's the length of the whole axis from one vertex to the other or one covertex to the other. Because if the distance from the center to one edge, again up here from the center to one edge has a distance of a, and this has a distance of a, to get all the way down, it's twice a. Or same thing from here. This is b and b, so the whole length is 2b. So these are your standard equations. All right, it looks almost like a circle. All right, it has an x squared plus a y squared, but instead of r squared, it's always a 1. This right here will always be 1, never another number. All right. And for a horizontal axis, the a squared is over the, or sorry, underneath the variable x, because horizontal is same as, kind of think about an x-axis. It's like this. So we want the longer distance to be under that axis. And if you look at the other one, again over here, this is my vertical axis. Again over here, always 1. You notice the only difference between the vertical axis and the horizontal axis in terms of the equation is that the denominators are flip-flopped. So again, your longer axis always needs to be under the one that is considered your major. So vertical axis, again, runs this way. Now, to be able to find your foci, or that letter C, you have this special equation right here. So because the foci lie specifically on the major axis, and there's C units from the center, we have a formula, A squared minus B squared equals C squared, so that we can find that. So let's do a couple of small graphs so you can see what you're going to be expected to do. All right, so we need to find the center, vertices, co-vertices, etc. All right, so you can see that it's in the standard form equal to 1. You want to recognize that this 9 right here is my A squared, and this is my B squared. All right. Your larger denominator will always be your A squared no matter what, every time. So if my larger denominator is always A squared, right, if my A squared is 9, that means that my A value is just 3. Right. And if my B squared is 4, that means my B value is 2. Right. My center right now is at 0, 0. Right. And so there's a couple different ways to graph this. I'm actually going to identify these vertices, co-vertices, and foci in a minute. All right, but let's kind of move over here to this graph. All right, I'm going to label my graph so that way I can see some values here. I don't want to eyeball anything. So I'm just going to label the 2's. Okay. So again, you want to be able to put your center on the graph, and then your major axis, again, if I kind of go back over here, the larger denominator is underneath the x, and so that means that my major axis, right, is horizontal. All right, which means I'm going to be graphing my vertices and my foci on that axis. All right, so again, I'm just matching up what this format looks like in terms of the bigger denominator under x with my original. So what I'm going to do is, because going from the center to a vertex is a units away, I'm going to count 3 units out. Okay. Those are my vertices. I'm just going to put a little V next to those so I know that those are my vertices. And on the minor axis are my co-vertices, and that is the distance of B. So I'm going to count 2 units out, and I'm going to label that CV for co-vertices. Right. And then I'm going to sketch my graph. Right. And so you can see that it's almost like a circle, a little bit wobbly. Right. Then I'm going to go back over here, and I'm going to actually write down the coordinates of my vertices and my co-vertices. So my first vertex is here at the coordinate 3, 0. And then my other vertex is over here at the coordinate -3, 0. Right. Now to find my foci is the equation c squared equals a squared minus b squared. So what that means is that the c value is going to be plus or minus the square root of 5. Now we don't always know what the square root of 5 is. All right, I don't know where to find that, so I'm going to approximate it. I know that the square root of 4 is 2. So this is about 2.1, 2.2. And so what that means is that going from the center, I need about 2.1 units to get to a foci. So that's going to be about right here. So that's a foci. Same thing this direction. 1, 2.1, that's going to be a foci. And so what you need to realize too is that you need to actually write down what those coordinates are. So if I'm starting from 0 and I added 2.1 units, I'm going to get that it's going to be 2.1 and 0 as one coordinate, and negative 2.1 and 0 as my other coordinate for my foci. And then again, all I need to look for is my covertices, which is here at 0, 2 and 0, negative 2. All right. All right, and so this is what you're going to be doing when you graph ellipses.